Hello everyone, my name is Pranit. Today we are going to discuss the topic about KRUSKAL'S algorithm. In this video, we are going to discuss that KRUSKAL'S algorithm and where we use the KRUSKAL'S algorithm in daily life also. For more about knowing the KRUSKAL'S algorithm, we want to know what is spanning tree. Let's move to the topic spanning tree. Mm. Here the spanning tree is displayed and the definition. Yeah, move to the definition. Assume that G it is a connected graph. Let G be a connected graph and T is a subgraph of G. T is a subgraph of G. When T is a subgraph of G, when it satisfies the both conditions given below that. If T is a tree and T contains all the vertices of G, then it then it is a spanning tree. Let's see to know more about it. Let's see the examples. Here the example for spanning tree. In this both, one is a spanning tree, one is not spanning tree. Uh, See this both diagrams with the three vertices, but one with three edges and another with two edges. Here we give a name that a cyclic with a T tree and cyclic with the G tree. The first we satisfies the both conditions to know about which is spanning tree. First condition is what's first condition? If T is a tree, if T is a tree, it should condense all the vertices of a G. Both are trees. And second condition, it should satisfy that T should condense all the vertices of G. But he did not mention that it should contain all the edges. It should contain only the vertices of G. So here three vertices, but here three edges, here two edges. We not bother about the edges. Only we should see only three vertices of G should contains in the tree graph. Then we can say this is a spanning tree. Now we are moved to the subtopic of this spanning tree called minimum cost spanning tree. What is minimum cost spanning tree? Minimum cost spanning tree is nothing but finding the optimal solution for connecting all nodes with minimum total edge weights. We see the in detail. We see that definition in detail. Let's see. Let us assume that G be a graph and suppose there is a positive real number associated with each edge of G. Then the G is called a weighted graph. Next point is spanning tree, whose weight is the least is called minimum spanning tree of a graph. Here we get a certain graph, but it is not a unique. We get different. For one question, we get to two different types of graphs. It is not a unique graph. We getting that minimum. Let us move to next minimum cost spanning tree. There are two algorithms to find the minimum cost spanning tree. They are Prim's algorithm and KRUSKAL'S algorithm. Now in this video, we want to discuss only about the KRUSKAL'S algorithm. But we get the same minimal cost in both Prim's algorithm and KRUSKAL'S algorithm. The answer must be same, but process is different. In this video, we only wants to discuss about KRUSKAL'S algorithm. Now move to the process. In this KRUSKAL'S algorithm, there are three steps. Step 1. Sort all the edges in a non-decreasing order for their weight. See this graph given above the step 1. A, B, C, D, E, F. F 1, 2, 3, 4, 5, 6. 6 nodes. Graph with 6 nodes and the edges are given with edges are assigned with some weights. We want to arrange arrange it in increasing order, increasing weight order. It is a step one in the Kruskal's algorithm. And step two. Step two is nothing but start with the smallest weight edge. Start with the smallest weight edge. Proceed sequentially by selecting one edge at a time, such that no cycle is formed. It means that first you want to select the smallest weighted edge. Then sequentially, in increasing order, we want to select all the edges. All the edges is nothing but we see in further step three. All the edges is nothing but we select all the edges, but that edges must not be cyclic. If it seems to cyclic, we didn't take that edge. We didn't consider that edge, and it should contains that n vertices, but n minus one edges. Now we move to step three. That step three in the Kruskal's algorithm is stop the process at step two when n minus one edge are found. Select these n minus one edges for a minimal spanning tree of a G. It means stop the process at n minus one edge. Stop the process of step two when n minus one edge is found. If in this step above the graph given above the step one, see there we got one, two, three, five, six edges. It means n is equals to six. We want to stop the step two process when n minus one. It means we get five edges are found. Select this n minus one edge for a minimal spanning tree of G. Then key concepts for the Kruskal's algorithm. Edge sorting, it's a first concept, and second is cycle detecting, and third is optimally. Edge sorting means arrange edge based on their weights. It means arrange all the edges based on their weights in ascending order, in increasing way. And second main point, second key concept is cycle detection. It must arrange the edges, but it should not be closed. It should not be cyclic. If it seems to cyclic, we ignore that edge and consider another edge. In optimally guarantees that the minimal total edge weight of the connecting all nodes. We get a guaranteed minimal total edges. After connecting all edges without cyclic in mode, then adding all, we get the minimal edge, guarantee the minimal total edges weight. Then algorithm steps. First step, sort all the edges in a non-decreasing order of their weight. A non-decreasing order, it means increasing order. Say, arrange the edges in an increasing order. And step two, select the first smallest edge and check it if it forms a cyclic with the spanning tree formed so the far. It means arrange the first, we should take smallest edge, and in sequentially increasing order we should take, but it check it not forms a cyclic, then it is a point. Second step, and then third step, add the edge to the spanning tree if it does not form a cycle. Then you move to here the real world applications of Kruskal's algorithm. Kruskal's algorithm is used in the communication telecommunication networks and in circuit designs and transportation systems for coefficient connectivity. In real life, this in this way we can use the Kruskal's algorithm. Next, move to comparing algorithms. Comparing algorithms. There are two types of algorithms: Prim's algorithm and Kruskal's algorithm. To find the minimal MST, it means minimal. It means minimal spanning tree. MST means minimal spanning tree. We use the greedy approach process. We use for both. We use the greedy approach process, and edges are added in ascending order of weight. In this, vertices are selected in ascending order or weight. In this, we use edges in ascending order. In this Prim's algorithm, we use the vertices should be arranged in ascending order. Then move to the complexity analysis. Complexity analysis is nothing but in this we use that minimum heaps process, minimum heaps data structure. From the minimum heaps data structure, we get O of E log V. And number two is space complexity. From the data structures, we get that O of E plus V. And three, where E is equals to edges and V is equals to vertices. Yes. In this E and it means E means edges and V means vertices. Now we discuss one problem on this KRUSKAL'S algorithm.
It's about the KRUSKAL'S algorithm now. Now we practice one example for the KRUSKAL'S algorithm. Here is example. This is a graph which contains 1, 2, 3, 4, 5, 6 vertices and 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. Now we know that the in KRUSKAL'S algorithm the process contains three steps. In that first step is we start first step. Write as usual, given here. First edges weight selected, then write least weighted edge. First in this graph we have least weighted edges BD 2 with 2 and DE with 2. Then write both. First take any one of these two. Now we should take that BD weight is 2 and DE weight is 2. And now next smallest weight is 3 CD, right? Edge is CD and its weight is 3. And the next smallest weight is BE with 4. B BE with 4. Now AC also there with 3. AC with 3. Next AB with 5. AB with 5. Next smallest weight is BC with 6. BC with 6. And AF with 7. AF with 7. And FC with 8. Now now this third column selected yes no, the given yes no now. How it is come means I will say now. This comes from step 2. What is the step 2? Arrange the edges in non-decreasing order. First small weighted edges BD with 2. BD, right? BD. And then next small weighted edges DE with 2. DE. Yes, it satisfies now. Then write S. Then CD. When it doesn't satisfy, it means when it uh, when it forms a cyclic. When we combine the edges, it forms a cyclic. Then it not satisfies. So it should not form a cyclic. Now next is CD with weight 3. There is CD. C. Now next AC. Next write S here. And next BE. If we combine BE, then it forms a cyclic. No, it not satisfies the KRUSKAL'S algorithm. It is not a point in the KRUSKAL'S algorithm, so we avoid BC. We should not take BC edge. So right here now. And AB. If we take AB, it forms a cyclic, so we avoid AB also. And next is BC. If take BC, it forms a cyclic, so we avoid BC also. Right now here. Next smallest weight is AF. We should take AF. It not forms a cyclic, so we should take AF. Then next FC. If take FC, then forms cyclic, so avoid FC also. Then what is step 3? 3. What is step 3? Avoid the process of step 2 when in vertices, and avoid the process of step 2 when n minus 1 edges is formed. It means n minus 1 edges means 1, 2, 3, 4, 5, 6. 6. Here n is equals to 6. N minus 1 edges, it means 5 edges. N minus 1 is equals to 5. N minus 1 edges is found. Therefore, 1, 2, 3, 4, 5, 6. Total 6 edges. 1, 2, 3, 4, 5, 6. N minus 1 edges we want. 1, 2, 3, 4, 5. Edges is equals to 5. Edges is equals to 5. So we got edges 5 and vertices 6. Then we stop the process at there only. This is the KRUSKAL'S algorithm sum solved. Thanks.